NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math tutorial. Today, we'll be solving a cubic equation step by step, following a specific algorithm for certain types of cubic equations. First, let's recall an important identity for cubic expressions. The cube of a sum or difference can be expanded as a plus or minus b cubed equals a cubed plus, or minus 3 a squared b plus 3 ab squared plus, or minus b cubed. This identity will be crucial for our method. Now, let's solve a specific example. Find the roots of the cubic equation. X cubed minus 3x squared plus 3x minus 4 equals 0. Looking at this equation, we should try to recognize if it matches any patterns. Notice the coefficients: 1, -3, +3, and -4. The first three coefficients 1, -3, and +3 match the pattern of the expansion of a binomial cubed, specifically x minus 1 cubed. Let's rewrite our original equation by grouping the terms that match the x minus 1 cubed pattern. We get open parenthesis x cubed minus 3x squared plus 3x minus 1 close parenthesis minus 3 equals 0. Now, let's recognize that the expression in parentheses is exactly x minus 1 cubed, so we can substitute it, giving us x minus 1 cubed minus 3 equals 0. Let's isolate the term x minus 1 cubed by adding 3 to both sides of the equation. We get x minus 1 cubed equals 3. To solve for x minus 1, we need to take the cube root of both sides. This gives us x minus 1 equals the cube root of 3. Finally, to find x, we add 1 to both sides of the equation. This gives us our solution, x equals 1 plus the cube root of 3. Let's verify our solution by substituting x equals 1 plus cube root of 3 back into the original equation. We need to calculate 1 plus cube root of 3 cubed minus 3 times 1 plus cube root of 3 squared plus 3 times 1 plus cube root of 3 minus 4. This computation would confirm our solution is correct. Let's summarize what we learned. To solve this cubic equation, we first recognize the pattern of x minus 1 cubed in our equation. Second, rearrange the equation to isolate this cube. Third, took the cube root, and finally, solve for x. This method is particularly useful for equations that can be written in the form x minus a cubed equals b. Let's look at our first example. First, we're going to rearrange the equation to group similar terms. We notice that we can factor out a common expression by grouping x cubed minus 3x squared plus 3x minus 1, and then subtract 8 from both sides to get 0. Next, we move the -8 to the right side of the equation, so we have x cubed minus 3x squared plus 3x minus 1 equals 8. Now, we have an important observation. The expression on the left side matches the pattern of a cube of a binomial. Specifically, it matches the pattern of x minus 1, all cubed. Now, we need to find the value of x minus 1. We take the cube root of both sides. The cube root of x minus 1 cubed is simply x minus 1, and the cube root of 8 is 2. Finally, we solve for x by adding 1 to both sides. So x equals 3 is our solution to the first cubic equation. Let's move on to our second example. We'll solve the equation x cubed minus 3x squared plus 3x plus 26 equals 0. Again, we'll start by rearranging the equation. We group the first 3 terms, which gives us x cubed minus 3x squared plus 3x minus 1, and then we add 27 to make it equal to 0. Next, we rearrange this to isolate our cubic expression. This gives us x cubed minus 3x squared plus 3x minus 1 equals -27. Now, we need to take the cube root of both sides. The cube root of x minus 1 cubed is just x minus 1. And the cube root of -27 is -3. Finally, we solve for x by adding 1 to both sides. This gives us x equals -2 as our solution. Let's summarize what we've learned about solving cubic equations. When we have a cubic equation in the form of x cubed minus 3x squared plus 3x plus d equals 0, we can try to rewrite it in the form of x minus 1 cubed equals some constant. Once we have it in that form, we can take the cube root of both sides to find x minus 1, and then solve for x. In our examples, we found that for the first equation, the solution was x equals 3 for the second equation. The solution was x equals -2. This method works well for cubic equations that can be written as a perfect cube. For other cubic equations, you might need different approaches like the factor theorem or synthetic division. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.